Hey guys, Mac here, and we are going to work on solving quadratic equations by any means necessary. Now, you can solve all of these by using quadratic equations. Right here, I could go a equals 3, b equals negative 12, and I would do a c equals 0 because there is no c. But don't do that, because I can look at this right now and just realize, hey, step number 1 is factor out anything common. So right here, I can pull out a 3x. What's left over? X minus 4 equals 0. Now I see I have two factors. And if I can make either one of those equal to 0, I'm going to win. 3x equals 0. X minus 4 equals 0. Divide each by 3. X equals 0. Add 4. X equals 4. So why do a quadratic equation when you can just factor out? So that's the first step, is you always ask yourself, what's the same? Okay, let's go on to number 2. Okay, what's the same? Nah, doesn't work. Okay, so I can't pull anything out. So now my next step is to try to do one of these. Okay, third term positive. Signs are the same. Take the sign of the middle. Okay, what factors into 12 and adds 7? Is there anything? 4 and 3. Boom. Okay, now, if I couldn't find anything, then I'd have to go to another method. Okay, and because this is odd, I would have gone quadratic equation. If it was even, I might have done complete the square. Okay, but now, since I could do this, I want to make this 0, and I could do that by making x negative 4. I want to make this 0, and I can do that by making x negative 3. And that's all we do. Okay? So now let's go to this one. Now here, is there anything I can factor out? Yeah, look at that. I can factor out a 2. I'm going to have an x squared plus 7x plus 12 equals 0. Now, do I care at all about that 2? The answer is I don't at all, okay? And I get basically the last problem, didn't I? Okay, so now that was random, but it was kind of funny how that worked out. Third term positive, signs are the same. Take the sign of the middle. What factors in the 12 and adds the 7, 4, and 3. I need to make each parenthesis 0, so that's going to be a negative 4, and that's going to be a negative 3. But remember, my first step was to pull out a greatest common factor. If I would have done a equals 2, b equals 14, c equals 24, would I have got the correct answer? The answer is yeah. It would have been nasty. You would have had really big numbers. But yeah, it would have worked. You would have got the right answer. How about this one? Third term, am I going to find any factors of 3 that are going to add up to 8? And the answer is no, I'm not. Okay, so I can't factor this one. This one is going to have some kind of a radical for an answer. So now here's a question. Do I go a equals 1, b equals negative 8, c equals 3? Yeah, I could. Okay, but I think it's a little quicker because I see that this is an even number. I'm going to take a stab at complete the square. So I'm going to subtract 3 to both sides, and I'm going to get x squared minus 8x equals negative 3. Now, what's half of 8? 4. What's 4 squared? 16. So I'm going to add 16 to the left, which means I have to add 16 to the right. Now, once I do that, this is in the trinomial square form, which means I'm going to go x. I'm going to take either the square root or half of the middle. You can think of it either way. Okay, and a minus sign squared equals 13. Now I'm going to square both sides. I'm going to get x minus 4 equals plus or minus root 13. And now that I add 4 to both sides, boom, die, x equals 4 plus or minus root 13. Now here's the cool thing. If you love complete the square, really nice when you got that middle term even. If you hate complete the square, but you're cool with quadratic equation, just do it. Just use quadratic equation. You would get the answer. You'd be fine. Okay, so the only time, if you don't like complete the square, the only time you have to use complete the square is if the direction literally says complete the, solve by completing the square. Now this one, well, it's up to you. You can go straight to quadratic equation, and because this leads with a 5, that would be the one I would use. But first, let's see if we can do this. 5x and x and a 1 and a 1. There's not a lot of choices, so I can do it. I know my signs are different and they have to subtract the 2. Well, my outies are going to be a 5, and my innies are going to be a 1. I'm not getting the 2, am I? I'm not. So now that I've done all that work, which wasn't a lot, was it? I can realize, okay, I can't factor this out, so I have to use one of the others. And the one that makes the most sense to me here is a quadratic equation. A equals 5, B equals 2, C equals -1. You guys remember the formula? Opposite of B plus or minus the square root of b squared minus 4ac all over 2a, which is going to become -2 plus or minus square root of 4 plus 20 all over 10, which is -2 plus or minus root 24 over 10. Square root of 24 is just 8 times 3. 8 becomes, well, you should start seeing that as 2 root 2 at this point. Okay, but I also have a 3. Well, none of that's going to be helpful to you. I did a little bit too much in my head because I've been doing these for a while. 2 times 2 times 2. There's a pair of 2's. So this is really 2 root, what's left over? 6. So this is going to be -2 plus or minus 2 root 6 over 10. And I'm going to reduce both these 2's, okay, to that. So my answer is -1 plus or minus root 6 over 5. Okay, let's go on to number 6. Okay, oh, that's the difference of 2 squares. I see a perfect square minus a perfect square. Your brains just go ding, ding, ding. I've seen those before. And what you do is you square root the first, you square root the second, signs are opposite. Now, to solve, I need to make each one of these parentheses 0. This one's going to be -7. This one's going to be +7. And I'm done. All right, let's go on to number 7. First thing I do, what's the same? Can I pull something out? Yeah, I can pull out a 4x. What's left over? X minus 5. Now I just make both of these equal to 0. 4x equals 0. X minus 5 equals 0. Divide each side by 4. X equals 0. This one I'm going to add 5. And I'm going to get x equals 5. Okay, so again, what's the same? What's left over? Do your factoring first. And then this one, I can look at this right now and know there ain't no factors of 2 that are going to add to 6. But I could complete the square though, couldn't I? All right, so I'm going to do that. I'm going to move my 2 over here and get x squared plus 6x equals -2. Now, what's half of 6? 3. What's 3 squared? 9. So I add 9 to both sides. And the whole purpose of that is to get that in the trinomial square form, which is going to be x plus 3 quantity squared equals 7. Now I'm going to square root both sides, and I'm going to get x plus 3 equals plus or minus root 7. I'm going to subtract 3 from both sides. Always write the constant in front of the plus minus. So that's going to equal -3 plus or minus root 7. Bingo. All right? So there you go. We kind of mixed them all up there, and hopefully that helped you find them. You want some more practice solving these? I'll see you on version A. Take care, y'all.